notes for investigating quadrilaterals. We're going to make sure we're measuring everything. So angles A, B, C, and D. If you extend these lines and you measure that angle, you'll see that it's right there at 90 degrees. Might be kind of hard to see. Let's focus that. Right at 90 degrees. Spoiler alert, they're all 90 degrees. Oops. Okay. So 90 degrees, 90 degrees, 90 degrees, 90 degrees. So all the angles are right angles, right? The right angles is from here. Okay, let me measure AB. Now, when I use the side of my protractor, it's about 2 inches. And then, spoiler alert, each side is also going to be 2 inches, 2 inches, 2 inches. So these are all congruent. They're all 2 inches. Okay. So, all sides of the square are congruent. Remember that word? Same size, same shape, same measurement. Opposite sides are what? Now, this you have to notice, okay? If you have two sides and their consecutive angles or right angles, those are going to be parallel lines. So these are parallel, these are parallel, parallel, right? Using it out of our word box. So these are the properties we need to know about a square, is that we have congruent segments, all angles are right, and all the opposite sides are parallel. Down here, a parallelogram. Okay, let's measure JKLM. Now for J, I'm gonna line it up. Take a look, and it hits right here. Since that's obtuse, I'm gonna use the bigger number, which is 120 degrees. Okay, down here at L, across the way, I'm gonna do that one first. That's also obtuse. That's 120 degrees. Okay. Angle K, line it up, measure it. Now, this looks like 120, but that's acute. So we have to use the smaller number, so 60 degrees for K, and spoiler alert, M will also be 60 degrees. So you can think of this is congruent to this, and then this is congruent to this. These opposite angles are congruent. Okay? Opposite angles of the parallelogram are congruent. Okay, so JK. Now, this is going to be kind of rough. This is about 2 and about 1/4. I know it's a little bit past that, so we're going to just make sure we go to 2.25. And down here at ML, it's actually the same, 2 1/4, 2.25. So these are congruent. KL, however, is more like 1 1/2. I know it's a little bit more, but we're going to, for the sake of time, kind of round it. Okay, so, and then these opposite sides are congruent. So the opposite sides are congruent. And what? Now, just like the square, we see, since these consecutive angles are supplementary, you can fill that out at the bottom, supplementary, then we know that these two sides are parallel. And it's in the name, and that's what makes a parallelogram a parallelogram. You got parallel sides, JK and ML. And you got parallel sides, KL and JM. Okay, so again, opposite sides of a parallelogram are congruent and parallel. Opposite angles are congruent, and consecutive angles of a parallelogram are supplementary. All right? Flip that over. Let's talk about a rectangle. Okay. Spoiler alert on these angles. Okay, you measure them, you're going to get 90 degrees for each one. They look like 90. I line it up, I get 90. I could do that on every single angle. I'd line it up and I get 90. Okay, so when you measure that, you'll see that. 90, 90, 90, 90. So all angles are right angles, again, just like the square. Fill that in. Let's measure. So EF. Alright, so again, this is kind of not exactly on where I'd like it to be. We're going to go to 3.25. Again, if you are more precise, that's cool. The point is, are we seeing what matches up here? So down here, again, it's about the same thing, 3.25 for HG. So kind of like the parallelogram, the opposite sides are congruent. FG on the side here, we'll give that a 1.75. And then over here, looks like the same thing. 0.75 right here. So these opposite sides are congruent, and you guessed it again, just like the square. If we have consecutive supplementary angles, these are also going to be parallel lines. So they're parallel. Okay? And this is all stuff you could have done on your own as you were going through this. Alright, now a rhombus. Okay, people call it a diamond, but we're going to call it a rhombus. Okay, we need to know the properties of a rhombus, so let's measure N. Line it up. It's right about 60 because it's acute. Okay, and by the way, let me back up and put inches on these. These are all inches, 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 inches. And my bad, on the front side, these should have been inches, 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 inches. Okay. Bring it back. Alright, and across, let's just do this one because it looks like it might be the same. Look, it is. It's 60 degrees. So angle P, 60 degrees. Angle Q is obtuse, so we use 120. Angle O, we use the bigger number, 120. So it's 120 degrees, 120 degrees. Okay. Again, these opposite angles are congruent, and the consecutive angles are supplementary. So opposite angles are congruent, and consecutive angles add up to 180, 60 plus 120, right? They're supplementary. All sides of a rhombus are what segments? Let's find out. Let's measure, measure, measure. All right, so on this one, we got about 2.25, 2.25, 2.25, 2.25. All right. Again, it's a little bit more than that. We're kind of snapping it to the closest quarter. And these are all in inches. Now, what do we notice about all these sides for a rhombus? They are all congruent, kind of like a square. The difference is these angles are not all congruent. It's kind of like a square shifted over a little bit, all right? Kite, very important. On a kite, let's measure R. Now for this one, we definitely want to be precise. Let's try to extend this line. Oh, no, extend this line. So I'm going to line this up. Now this is pretty close to between 60 and, not 60 and 70 because this is obtuse. It's between 110 and 120. Sorry, you can't really see that. Let me pull that down. Okay, I lined it up on the vertex. I see the line goes right here. It would keep going. It has to be the obtuse number. So if you put 65, that's wrong because that's an obtuse angle. It's going to be 115 for R. Okay, so we got R, 115 degrees. All right. All right, let's try S. Okay, let's maybe extend it a little bit. So at S, I line it up. Now this S happens to be right on the 90, right on the money, so to speak. Okay, so S is 90 degrees. I'm going to put 2 arcs on this. Okay, S is 90. Let's do T down at the bottom. Line it up. Okay, so this one's, again, it's acute, and it's between 60 and 70, so we're going to put 65 for T. And then U. U is right on 90 again. All right, so notice these opposite angles are 90. R is an obtuse. T was an acute. Okay. So there's only one pair of angles that are congruent. Okay. So Kite has one pair of opposite angles that are congruent. They're both 90. Now they're not always 90, but they're always going to be the same across from each other right here. Okay. Let's measure these sides. RS. RS is about 1 1/4. RU is about the same, 1 1/4. RS and RU. Let's do ST. ST is about 2 1/4. U is about 2 1/4. So you'll notice these are the same, these are the same, and these are the same in a kite. So these are consecutive sides that are congruent, and another pair of consecutive sides that are a different length, but also congruent. So a kite has 2 pairs, different pairs, of consecutive sides that are congruent. It's very important that we see that, we'll call it the top of the kite has 2 congruent sides, and the bottom of the kite has 2 different congruent sides with congruent angles across from left to right, if it's positioned like that. Okay, let's talk about a trapezoid. Angle W looks like 90. What do you know? It's 90. If you continue that line, there's 90. Looks like Z is 90. What do you know? If you keep it going, it goes 90. Okay, so W and Z are 90. Let's measure these. So angle X, we line it up. It's obtuse between 110 and 120, so it's 115. And then with Y, we line it up. It's between 60 and 70. It's acute, so 65 degrees. All right. WX is about 2.75 inches. XY is about 1.5 inches. ZY is about 3.5 inches. WZ is about 1.5 inches. So XY obviously is not the exact same length. It's more like, we'll go with 1.7. Sorry to make y'all erase here. All right, trapezoid has one pair of opposite sides that are what? Okay, so the main thing about a trapezoid, none of these opposite sides are equal, right? But the one thing that's true about a trapezoid, again, because these are supplementary and because these are supplementary, we know that WX and ZY have to be parallel. And those are called the bases. We have one pair of parallel bases. All right. Last part, you have to know how to do mid-segment theorem, and it's super easy. And here's one example. The mid-segment of a trapezoid is a parallel of each base. Okay, so let's say you got your trapezoid, parallel line, and X and Y are called the midpoint. Okay, so remember, mid-segment is made by midpoints. So X is a midpoint, tick, tick. Y is a midpoint, double tick, double tick. So here's the rule right here. all you got to do is add up BC and AD and then find half, right? So basically I'm going to be doing 1/2 5 plus 9. Or you can write it as like this, 5 plus 9 divided by 2. Either way, right? So hopefully you know 5 plus 9 is 14, 1/2 of 14, or 14 over 2, because we're using these numbers, 5 and 9, right? So what's half of 14? 7. Doesn't give us units of measure, but 7, okay? That's it. So again, if you have the parallel bases, you can find the mid-segment by finding the average of those two sides. You add them up and divide by 2. Okay, and that'll help you do it on the assignment when you get there.